9.5 example 6. Before we dive into example 6, I want to talk about the intervals of convergence. This whole section is called testing convergence at endpoints, and now we've learned every test that we can use. So now we can talk about how to determine if the interval will include the endpoints or not. So first of all, when we talk about convergence, there are three outcomes we could have. The first one is diverging. We can converge absolutely, or we can converge conditionally. And you know you converge absolutely when you involve absolute value bars. And you know you converge conditionally usually results when you use the alternating series test. So the first thing we're going to talk about is how to test a power series of the form c sub n times x minus a to the n. And what that means is you have c sub n is like 1 over n or n over n plus 1 or something like that, times x minus a to the n, where a is a number and n is also a number. Step 1 is we use the ratio test to find the values of x which the series converges absolutely. We usually get an open interval, a minus r is less than a plus r. And sometimes it converges for all values of x. This is when the x term will go away, or you just get a number less than 1. And in rare cases, it converges to a specific number, x equals a. And this is when something weird will happen where only one x value will make it converge and it diverges everywhere else. The second thing you do, if the interval of convergence is finite, which means it's a number, then you have to test for convergence at each endpoint. So if we get that inequality, like 5 is less than x is less than 3, we have to test these two endpoints to see if they're included in the radius of convergence. And we use the integral test, the comparison test, or some alternate series test. If the interval of absolute convergence is a minus r is less than x, which is less than a plus r, we conclude that the series diverges when x minus a is greater than r. So if you get that x minus a is greater than that r value, then it will diverge, because the values of x to the nth term do not approach 0. All this means is that when you take the limit and as n goes to infinity, you don't get 0. And in other words, if the series converges from between x is negative 5 and 3, then it's going to diverge when x is less than negative 5 and when x is greater than 3. You can think of that like it diverges everywhere where it doesn't converge.